Hi, welcome back. What we're going to do next is practice a little bit with the table of operations I gave you before and graph some functions in our xy axis, alright? We're going to just make like additions and subtraction to the function in general or to the argument, just like I said before, and see that there's nothing to be afraid of when seeing something like plus k minus k, whether it's inside or outside the argument of the function. We're going to draw a huge y-x axis, and there we go. We're going to draw some examples of the functions right here on the left side, and we're going to chart them as quickly as we can, and we're going to see that there's nothing to be afraid of. This is just routine procedure. You can just get to this level by practicing over and over and seeing the patterns that the functions follow, right? It's all about the patterns. Normal, basic functions always follow a pattern, okay? So let's start with something like y equals 4x squared plus 3. So what do we know about this function? Well, we know that the a is 4. That means that the convexity of the function is going to be up. The concavity of the function is going to be pointing up north. It's a positive 4. It's a high number, so we know that it's going to be wide open. It's going to be a little bit closer, okay? And the 3 tells us that the cut with the y-axis is going to be happening occurring at 1, 2, 3 spaces above the 0. So what? We're going to chart that. 1, 2, 3. And there we go. That's y equals 4x squared plus 3. It's a positive up concavity function square moved up 3 spaces to the north. Let's do another example. Let's say y equals x plus 1 squared. Alright, what do we know about this function? Well, given the fact that we have a plus 1 x argument inside the function, we know that it's a quadratic up concavity function moved to the right. Where? At minus 1, because minus 1 is the 0 for this function. So there we go, minus 1, right here. Okay, this is y, x plus 1 squared. Let's do another example. Y equals x minus 1 squared minus 1. Now this function has a little bit something different. There's a minus 1 inside the argument of the square, but there's also a minus 1 outside the function. So there's two things that we have to notice right here. Number one, minus 1 here means that the quadratic graph is pushed to the right, but the minus 1 here means it's also pushed down 1 space. So 1 to the right and 1 down. 1 to the right because it's inside the argument, and 1 down because it's outside the argument. So to do this, all we have to do is locate the space, displacement. We have 1 right here, and minus 1 right here. So we said 1 to the right because of the argument, and minus 1 because of the subtraction of the whole function. So we know that the quadratic, which would be around here, around this area, 0, 0, is going to be 1 to the right and 1 down. It's still positive because the x is positive 1. So it's opening all the way up like this. Alright? And you can notice easily that the vertex of the quadratic equation is right here in this spot. One minus 1. Okay? The same exact reasoning. So let's do another example. Y equals x cubed minus 4. So in a past video, we saw that the chart, the graph for the x cubed function is something like a snake. It goes up, then like this, and then it goes up again. But in this case, we have -4, so it means that it's displaced 4 elements down. So we count -1, 2, 3, and 4. -4. That's where the cut is going to be with the y-axis. The rest of the graph is exactly the same as if it was with x cubed. So it's going to look a little bit like this. There we go. This is y equals x cubed -4. See? It's the same exact plot of the x cubed function, only that displaced 4 elements south. Why? Because we have -4 right here. Let's do another one. Y equals -4, a constant function. Whoa, what do we do with that? I don't understand. Where's the variable? There's no variable. It's only a constant, -4. It's a straight horizontal line that is parallel to the x-axis. How do we graph that? Just do a horizontal line across -4. This is y equals -4. There we go. It's just a constant horizontal line that is parallel to the x. Let's do another one. Y equals -3x -2. What is this? Is this a quadratic, a cubic? No, it's just a linear function. The slope is -3, so it means it's negative. The function, the line is going to be like this, from the upper left to the lower right. -2 is the b, is the cut with the y-axis. This means it's going to be cutting right here at -2. So we know that the function is going to look a little bit like this. Let's use green again. Down and up. This is y equals -3x -2. There we go. See, all we're doing is using the operation, the table of operation of displacement that I gave you for the functions. This is what happens when you add or subtract a constant to either the function or the argument of the function. It's very easy to plot the numbers. All you have to do is understand where the cut is with the y-axis and how big is the slope or the degree of complexity or eccentricity that the function has. If I had something like, say for instance, y, let's use the black marker again, 8x cubed plus 1, well, that would mean that number 1, the function is one space displaced up. But it also means that the argument, the degree that the function grows is quicker. Okay? So 8 times x cubed grows quicker. If I would introduce a 1 in dx right here, we would have 1 times 8 plus 1 would be 9. Okay? So it grows quicker than the regular x cubed. And that would mean that the chart would look a little bit like this. Y equals 8x cubed plus 1. And as you can see, it cuts right here at 1. It's way more aggressive than the regular x cubed in green that you can see right here. Okay? We're going to practice a little bit more in another video.